Okay, so we are going to talk about how to find a determinant of a 3 by 3 matrix. And there's going to be two different methods. The first method I'm going to show you, we call the diagonal method. And for the diagonal method, let's say I have a 3 by 3 matrix that I'm going to find the determinant of. I have A1, B1, C1, then A2, B2, C2, then A3, B3, C3. So I'm going to write out sort of the formula for it, but you don't need to memorize the formula. I'm going to show you why we call it the diagonal method and sort of the shortcut to remembering how to group it together and what we add and subtract and all that good stuff. But if we're going to lay it all out, what we're going to do is we are going to find the product of A1, B2, C3 plus B1, C2, A3 plus C1, A2, B3 minus open up our parentheses, the product of A3, B2, C1 plus B3, C2, A1 plus C3, A2, B1. Luckily, you don't have to memorize this, but this is what it is. Can you write it on the test?
Oh, is it given on the test?
Nope, it's not. I'm going to show you how you come up with this.
It's like a visual representation.
Yeah. All right, so what do I mean? All right, what you want to do, I'm just going to jump right into an example because that's the best way to show you how to find a 3 by 3 determinant using the diagonal method. So I want us to find the determinant of this 3 by 3. Our elements are 2, 3, 5. You want to be super neat. So like if you scribble and like you don't use your lines, this might be hard for you. 4, 2, 1, -1, -3, 2. So what I want you to do is I want you to take all the elements out of the determinant lines. So we're going to take all the elements out of the determinant lines. So I have 2, 3, 5. Try to keep it super neat and in a line. 4, 2, 1, -1, -3, 2. Haven't changed anything, right? Now what I want you to do is I want you to take the first two columns, these first two columns, and then repeat them at the end. So now I'm taking 2, 4, -1, and 3, 2, -3. So I've taken all the elements out of the determinant lines, and now I've repeated the first two columns. What you want to do is you want to go to the very top left element, which is right here, 2. And then what you're going to do is you're going to go down on a diagonal from 2. And on that diagonal, you are going to multiply every element in that diagonal. So what am I going to multiply? 2 times 2 times 2, which is 8. Plus, now we're going to go to that next element, the one next to 2, which is 3, and I'm going to make a diagonal from 3. And guess what I'm going to do with all those elements in that diagonal? Multiply them. 3 times 1 is 3, times a negative 1 is negative 3. Now I'm going to go to the next element, the 5, and I'm going to make a diagonal from the 5, and I'm going to multiply all those elements in that diagonal. 5 times 4 is 20. 20 times a negative 2 is a negative 60. Bina, could you take your headphones out, please? Okay, now what we want to do is close up. So if I were to if you're like, oh, I don't know if I should do another diagonal, if I move on to the 2, could I get another 3 elements in that diagonal? No, so that tells you we're stopping, right? So that's the end of this parenthesis. We're not done yet. So we close this parenthesis, and now we write minus. Now we had started at the top left before. Now we're going to start at the bottom left and make diagonals up. So what do I mean? I'm going to start at the bottom left, so I'm going to negative 1. And I'm going to work a diagonal up there. And I'm going to multiply all those numbers in that diagonal. So I have negative 1 times 2 is a negative 2. Negative 2 times 5 is a negative 10. Plus, now I move on. So I start at negative 3 and I work my way up. Negative 3 times 1 is negative 3 times 2 is a negative 6. Plus our last diagonal. 2 times 4 is 8 times 3 is a positive 24. What we're going to do now is we are going to simplify each parenthesis. So I have negative 8 plus 3 is 5. 5 plus a negative 60 is a negative 55. Minus negative 10 plus negative 6 is a negative 16. Negative 16 plus 24 is a positive 8. So now I have negative 55 minus 8 is a negative 63. Okay, you want to try one of these on your own? All right, so this was 1. Let's call this 2.
Miss Abigail?
Yes?
What does negative 63 mean?
That's the determinant of those numbers.
But what does it actually represent?
Well, right now, it's just the determinant, but we're going to use this concept to help us solve systems of equations. So right now, it means nothing to you. It's just a number called the determinant, but we'll be using that determinant to help us solve systems.
Okay.
But we just need to practice it before we can apply it. Okay, you guys are going to find the determinant of this matrix. 2. And how do you know I want you to find the determinant of this? Ange? Because of the straight lines. If it were in the brackets, if it were in the square brackets, that would mean this is just like a set of data. But now I want you to find the determinant of this set of data.
This is negative 12.
This is negative 12.
No, no. This is supposed to be a negative 12.
Oh.
Listen. 1, 2, 3.
Negative 2, negative 2, negative 2, 2.
No, that's not negative 2. Oh. Let the column down. Oh, I saw it. It's game over. So what did you get?
Negative 36.
Well, you'd be wrong in the test if you didn't circle it.
I said circle. That was correct.
Negative 36.
What you do?
So what did you get? 27? Nah, what happens over here? 35 and 21?
All right. Do we have an answer?
I did.
You do?
Oh, no.
Dude.
Negative 36.
Negative 36.
Yeah, you were
Does anybody have another answer?
Do you objectify?
I have 34.
Scion?
28.
Positive 28.
So
Does anybody have a different answer? Caitlin? Positive 44.
Yeah, 44.
Does anybody have a different answer?
It's 44.
It is 44. All right.
What?
Clearly we need to do this, yes? All right, so let's list these out. Negative 3, 2, negative 5, 4, negative 1, 2, negative 1, negative 2, negative 3. We're going to, Alexia, turn around. Brandon, close your computer. All right, now we're going to repeat the first two columns, negative 3, 4, negative 1, 2, negative 1, negative 2. We're starting at the... Wait.
Never mind.
Oh, is that why we messed up? Does anybody need me to keep going?
I wrote it down wrong.
Oh, that's why. Okay, does anybody need me to do it then?
Yes.
Yes? You just
100%.
said
No, but
that's
that
why
doesn't
you
mean
got
I
it
didn't make any
wrong.
other mistakes, though.
You're killing me, Antonio. Okay, so we find our first diagonal. We're going to multiply the elements in it. So we have 3 times negative 1 is a positive 3 times a negative 3 is a negative 9. Plus, we now get to our next diagonal. 2 times 2 is 4 times a negative 1 is a negative 4. Plus, getting to our last diagonal in this parenthesis, negative 5 times 4 is a negative 20 times a negative 2 is a positive 40. Close your parentheses, minus, open up another set of parentheses. Now I'm working my diagonal from the bottom up. Negative 1 times negative 1 is a positive 1. Positive 1 times a negative 5 is a negative 5. Work our way from the bottom up. Negative 2 times 2 is a negative 4. Negative 4 times a negative 3 is a positive 12. Working our way up again. Negative 3 times 4 is a negative 12. Negative 12 times 2 is a negative 24. And then we add negative 9 plus negative 4 is a negative 13. Negative 13 plus 40 is a positive 27. Negative 5 times negative 24 is a negative 29. Negative 29 plus 12 is a negative 17. But this double negative makes a positive. So that brings us to 44. Okay, good. All right, so why did I show you this? It's going to be brutal. Ready? It's not hard, it's just tedious. It's not hard. So now what we're going to do is we're going to use Cramer's to solve 2x plus 3y plus 4z equals 4, 5x plus 7y plus 8z equals 9, 3x minus 2y minus 6z equals 7.
We use the coefficient thing.
So this is a 3 by 3 system. So remember, with Cramer's, we use determinants to solve systems. Now, determinants only work on square matrices. Will these be square matrices? Yeah. Okay, so remember, our first determinant that we find is the coefficient determinant. So we have 2, 3, 4, 5, 7, 8, 3, -2, -6. So we're going to find this determinant. I'm going to use the diagonal method. That's your only choice right now because it's the only thing I have shown you. I will show you another method.
Is it a better method?
No. I don't like it, to be honest.
We don't have to do it then.
But we do.
Oh, man.
All right, so now we're working on our diagonals. I've repeated the first two columns. So we're going to get 2 times, well, let's do -6 times 7 is a -42. -42 times 2 is a -84. Next column, 3 times 3 is 9, times 8 is 72. Next diagonal, 4 times 5 is 20, times a -2 is a -40. Close our parenthesis, subtraction sign, open up a new parenthesis. Now we work our diagonal from the bottom up. 7 times 4 is 28, times 3 is 84. Bottom up. -2 times 2 is -4, times 8 is a -32. And our last diagonal, -6 times 5 is a -30, times 3 is a -90. When we add the parentheses, we will end up with a -52 minus -38. That double negative makes a positive, so we will end up with D equals -14. Did I do something wrong? I could have done something wrong. -52, you're right, it's not 54. I still got it right, because in my head I did 52. Is this better? Yeah? Okay. So now, that is just the coefficient determinant. Who remembers in Cramer what we do next? Sean?
We get the D of x.
Good. Now we find D of x. How do we find D of x?
We put in the equals
Instead of?
instead of the x's.
Good. We're going to put the equal values instead of the x column. So my equal values are 4, 9, 7. And then the other two columns stay the same. So we are 3, 7, -2, and 4, 8, -6. Do you guys want to find this one on your own? You got this. Go find it on your own.
So we have to do the whole thing again?
Well, it's different now.
It's the same thing.
Okay.
It's the same process, just different numbers.
I didn't know if we had to do it.
You have to, this is what I said, it's not hard, just tedious. It's just time consuming and tedious.
How many little mistakes you gotta make?
I know, something.
Wait till we get to the calculator and you'll see how crazy it is, how we can do it on the calculator.
It's like my biggest weakness. It's not my
No, it's over, bro.
These two just keep talking, bro.
Dude, Brandon, why are you so hurt?
I know, that's what I was like. That's why I was over bothering. Why'd you make a mistake?
Let's do some peer review. Momentarily. Some big numbers. He's definitely the best. 172. Oh, it's not that one cheap.
Yep, still on 72.
Hey, no need to be rude, bro.
No, but you're counting that means you're still on 72.
There's no need, bro. That's so low. Running out of paper. No, you're definitely wrong.
It's definitely wrong, but whatever.
You get negative 42?
Yeah, actually.
It's right there.
Oh.
No, it's 100% wrong.
No, it's right. Brandon, you done?
All right, what do we get for dx?
Wait.
Wait, okay.
Oh,
No, don't wait.
I'm still like,
Let's just keep going.
not there.
You got the answer.
No, I'm not there.
Haley? Negative 42. I can't find my answer. I feel like that, yep, that's what I got also. D of x is negative 42. What do we do with this? Ange?
So I did not get that.
Good, so now x will equal d of x divided by d. So x will be negative 42 divided by d, which was a negative 14. Was it negative 14? Yes. So x will equal 3. Are we finished? How many more times do I need to do this? How many more determinants do I need to find? 2 times, 2 more. I have to do it for y, and what else do I have to do it for? Z. Do you need to see me do it more?
How do you get 72?
No, because if I say use Kramer's, you have to use Kramer's. All right, does anybody want to see me find dy and dz? Okay, I'll give you the answers in case you want to do it later. So dy, I'll give you the determinant, would be 2, 5, 3, 4, 9, 7, 4, 8, negative 6. And if you find that determinant, you get dy is 28, and y will equal negative 2. And then the other thing you need to find is dz. And if you do dz, we're 2, 5, 3, 3, 7, negative 2, 4, 9, 7. And when you find that determinant, you will get negative 14. So z will equal positive 1. All right, The next method I'm going to show you is called the minor method.
Was Z negative one or
Positive one. Z is positive one. All right, the minor method. So each element in a square matrix has its own minor. The minor is the value of the determinant of the matrix that results from crossing out the row and column of the element under consideration. I will show you what this all means. Okay, so let's say I want us to find the determinant of 12, 5, 6, negative 2, negative 3, negative 6, 5, negative 7, 3. Okay, do you see how we have 3 columns? To help me out, I'm going to repeat this 3 times. 12, 5, 6, negative 2, negative 3, negative 6, 5, negative 7, 3. Actually, I'm repeating it 2 more times for a total of 3. And then 12, 5, 6, negative 2, negative 3, negative 6, 5, negative 7, 3. All right, then what you want to do is go back to our first determinant. Above the first row, I'm going to write plus, negative, plus. Now this plus, negative, plus does not mean keep it positive, keep it negative, keep it positive. That's not what it means. The plus means keep the sign the same. The negative means change it to the opposite sign. And the positive means keep the sign the same. So when I say plus and it's a negative, that just means keep it negative. So that positive means keep it the same. The negative means change it to the opposite. The plus means keep it the same. Anybody need me to repeat that? It doesn't mean change it to positive, change it to negative, change it to positive. It just means keep the same, change, keep the same. We okay with that? Okay, now what we're going to do is we are going to focus on the very first element here, which is 12. And what you do with that element is you're going to cross out the row that it's in and the column that it's in. And then once you cross out the row and the column that it's in, aren't we left with a 2 by 2? That's what we're going to do then. So we're going to take that element that I circled. That's going to go on the outside. And because of the plus sign, it means keep it the same sign. What sign is this 12? Positive, so I'm keeping the 12 positive. Then what I'm going to do is I'm going to find the determinant of the remaining elements. -3, -6, -7, 3. Who remembers how to find the determinant of a 2 by 2 matrix? Adam?
I just have a question. Why are the -3s not 3s? Or, why is the
Oh, you mean because of the plus minus plus? That plus minus plus is only for the number going on the outside, because we're going to do this 3 times. So the elements inside stay exactly the same. And how do we find the determinant of a 2 by 2?
Multiply the top left by the bottom right, and then subtract the top right and the bottom left.
You got it. So basically we're multiplying on a diagonal and then subtracting the products. So I have -3 times 3 is a -9 minus -7 times -6, which is a positive 42. So now we have 12 times -51, which is a -612. Can I move on to the next one? I'm not done with this problem. So now I asked us to rewrite it 2 more times because we're going to do this 2 more times. So we have plus, minus, plus. So now what we do is we use this first row again, but now I'm going to go on to the second element in that first row. So my second element is 5. And I'm going to cross out the row that comes with 5 and what else that comes with 5? The column that comes with 5. I'm going to put that 5 in the front, but now the negative says make it the opposite sign. So what is the opposite of positive 5? -5. So here I have -6, oops, sorry, plus, back up here, plus -5 times the determinant of the elements that are left over, which are -2, -6, 5, and 3. So we're going to have -2 times 3 is a -6, minus 5 times -6 is a -30. So we end up with -5 times a negative, oop, that's not right. That double negative makes a positive. So -5 times a positive 24, which is going to be -120. We are going to do this 1 more time. So now I'm still in my first row, but which element am I going to now? The 6. I'm going to cross out the row that's with the 6 and the column that's with the 6. And remember, it's plus, negative, plus. So what does that mean now? What am I going to do? Make the 6 or make the 6 a negative or keep it positive? Keep it positive. And our elements that are left over are -2, -3, 5, -7. So we get positive 14 minus -15. That double negative makes a positive, so we end up with 6 times 29, which is going to be 174. So our determinant is equal to all of this added together, which is, did anybody add it? I feel like my answer is wrong. Negative 558. Does that sound right? All right, let's just pretend. All right. That is how we find the minors. Do you guys want to try one on your own, or do we want to stop here? How many people want to try one? Okay, I'll put one up and you don't have to do it. We could just even find the one we just did before. 2, 3, 4, 5, 7, 8, 3, -2, -6. All right, so I will give you the answer for this. Since the bell's going to ring soon, I don't think you'll finish, but I'll give you the answer.
I won't finish, but I am finished.
We get -14 here is the answer when you do this. So we'll stop here.